Yeah, this is concept 2 of unit 2, circles. We're going to talk about inscribed and central angles within circles. And we got a little more vocabulary to start. And an inscribed angle has a vertex that is on a circle. So down here, that's point B. The vertex is on the circle. And the sides of this angle, side BC and BA, they're chords within the circle, so their endpoints are also on the circle. We would say that this angle ABC is inscribed within the circle. And it intercepts an arc. Arc AB is the intercepted arc. The endpoints of the arc are the endpoints of the sides, and all the points, so the arc is contained within the angle. So it's sort of like a Pac-Man situation. The arc is being eaten by this Pac-Man sort of looking thing. And from that we get a theorem, and it has to do with the measure of the angle that's formed and a measure of the intercepted arc. And what happens is this angle, angle B, we'll just call it angle B for short here, and that's allowed. Angle B is equal to 1/2 the measure of arc AC. So that means if arc AC is 80 degrees, then angle B is 40 degrees. Go ahead and pause the video and try this example. It's a little more complicated than the one I just showed, but take your time, and then I will go through step by step and talk about how to find the measure of A and the measure of B. So if you solve this correctly, you should get that A measures 120 degrees and B measures 60 degrees. So let's look at this. A is the intercepted arc of angle PQT, this angle, and we can call that angle Q for short, and you should know that from the angle naming video. So we can use the relationship that the measure of the angle is equal to half the measure of the arc, and that's arc PT. Plug in what we know. We know that the angle Q measures 60 degrees. We know that the arc measures 8 degrees. And then to solve this equation, we multiply both sides by 2, and we get that A is 120. We can also see that this angle B is PRT, or angle R for short. It intercepts the same arc. So B is equal to half of A, and we can go through, plug in what we know, and solve, and get that B is also 60 degrees. Another theorem we have here is when we have a tangent and a chord intersect. So this is a little bit different than the tangent and the radius. AC is not a diameter. It isn't part of a radius. It's just a chord. It's intersecting with tangent here at point C. The minor arc they create, which is arc AC, and the angle they create, which is right here, are going to have a relationship that's very similar to the inscribed angle. So the measure of the angle that's created, and I'm going to throw another point on here, we'll call it point D. So the measure that's created of the angle that's created, angle C, is equal to 1/2 the minor arc that is created, and we'll call that arc AC. So it's the same relationship as an inscribed angle. So pause the video here. Given this information, try to find out the measure of angle PQR. So as always, you should label your picture with what you know. We're told that arc QP has a measure of 148 degrees. That's this minor arc formed by the tangent and the chord intersecting. And we're looking for PQR, which is the angle here that is formed by the tangent and the chord. So we can just use the relationship that the angle is half of the arc, plug in the value for arc QP, and simplify and get that the measure of angle PQR is 74 degrees. A different type of angle that we have within circles is a central angle. The name of this type of angle kind of gives away what it is. It's an angle that has a vertex at the center of the circle, so the center of circle B, and its sides are radii. So AB and BC are radii. And we have a relationship with the central angle and its arc that we will talk about on the next slide. And it's another theorem, and it's a pretty easy one. The measure of this angle, angle B or angle ABC, is equal to the measure of the arc that it creates. So this minor arc AB. So we can say that the measure of angle B is equal to the measure of arc AC. And somehow we got red there. Just a little bit of magic. Early Christmas present. So pause the video and try this example using your knowledge of central angles. So if you solve this correctly, you should get that the measure of angle BOC is equal to the measure of arc BC, and that will be 32 degrees. And the measure of angle COD is equal to the measure of arc CD, and that would be 58 degrees. So I have 3 questions for you to try. Make sure you submit your answers online. The link is in the description section of the video. As I've said in the past, make sure you click the link. It's the easiest way to avoid any problem in submitting your answers. So use your knowledge of inscribed angles, central angles, and tangent chord relationships to answer these 3 questions. Good luck.